So here we have the function x squared plus sine of x divided by cotangent of 2x. So we need to find out the derivative of this particular function with respect to x. So what we're going to do here is we're going to simplify the given expression. So we have 1 over cotangent of 2x. So the reciprocal of the cotangent function is the tangent function. So that means 1 over cotangent of 2x can be written as tangent of 2x. So that gets multiplied to the numerator, which is x squared plus sine x. So this has been done so that instead of applying the quotient rule, we can now simply apply the product rule, which is kind of simpler compared to the quotient rule. So we are going to treat tangent of x as the first function and x squared plus sine of x as the second function. So that gives us tangent of 2x multiplied to the derivative of the second function, which is x squared plus sine 2x, plus the second function, which is x squared plus sine 2x. Oh, this is simply sine x, my mistake. This is sine of x sine of x multiplied to the derivative of the first function, which is tangent of 2x. So we get tangent of 2x multiplied to derivative of x squared, which is going to be 2x, plus derivative of the sine function is the cosine function. So we have sine of x plus x squared plus sine of x multiplied to, now we have tangent of 2x. We know that the derivative of the tangent function is secant squared x if we had tangent of x. Since we have 2x, so this will become secant squared 2x, and that should be multiplied to the derivative of 2x, which is, we have assumed that if it were equivalent to x, then we should get secant squared 2x. This is the chain rule, so let's rewrite everything. So we have tangent of 2x, so this function is multiplied to 2x plus cosine of x plus x squared plus sine of x multiplied to secant squared 2x, and derivative of 2x is going to be simply 2. So this is the derivative of the given function with respect to x. Let's move on to the next question. So here we have the function e raised to the power of x multiplied to log of 1 plus x squared. So let us try to find the derivative of this particular function with respect to x. So we're going to treat e raised to the power of x as the first function and log of 1 plus x squared as the second function. So that gives us e raised to the power of x multiplied to the derivative of the second function, which is log of 1 plus x squared, added to the second function, which is log of 1 plus x squared, multiplied to the derivative of the first function, which is the exponential function. So we get e raised to the power of x multiplied to, now we're going to consider 1 plus x squared. We're going to imagine that 1 plus x squared is equivalent to x. So that means we have to find the derivative of log of x, which should give us 1 over x. Now x here is the imagined value equivalent to 1 plus x squared. So that means we need to multiply it to the derivative of the imagined value, which is 1 plus x squared plus log of 1 plus x squared multiplied to the derivative of the exponential function is the function itself. So we have e raised to the power of x divided by 1 plus x squared. Derivative of 1 with respect to x is 0, plus derivative of x squared with respect to x is twice of x, plus log of 1 plus x squared times e raised to the power of x. So that gives us e raised to the power of x. So we're going to take the e raised to the power of x as the common term. So we have 2x divided by 1 plus x squared plus added to log of 1 plus x squared. So this is the derivative of the given function with respect to x. So let us move on to the next question. So we have the function e raised to the power of x plus log of x divided by sine 3x. So let's try to find out the derivative of this particular function by using the quotient rule. So we have sine 3x in the denominator, so we square it and write it in the denominator. So that gives us sine squared 3x. Then we're going to start with the denominator, sine 3x, and multiply it to the derivative of the function in the numerator, which is e raised to the power of x plus log of x. Minus, since this is the product, the quotient rule, so we need to put a minus in the numerator. That will be the numerator, which is e raised to the power of x plus log of x, and this will be multiplied to the derivative of the denominator, which is sine of 3x. So that gives us sine 3x multiplied to, so we have derivative of the exponential function, so that is e raised to the power of x, the function itself, plus the derivative of the logarithmic function is 1 over x, minus e raised to the power of x plus log of x. This is multiplied to, now we have to find the derivative of sine 3x. Now if we imagine the 3 of x is x, then we should get cosine of x, which is the derivative of the sine function. But since it's not, so we need to multiply it to the derivative of the imagined value, which is twice x, all divided by sine squared 3x. So that finally gives us sine 3x, and this will be multiplied to the exponential function plus 1 over x minus e raised to the power of x plus log of x multiplied to 3 times the cosine of 3x. The 3 comes from the derivative of thrice x, all divided by sine squared 3x. So this is the derivative of our given function with respect to x. Let's move on to the next question. So here we have the function given by e raised to the power of ax multiplied to cosine of bx plus c. So we're going to find the derivative by applying the product rule. So let's treat e raised to the power of ax as the first function. So this will be multiplied to the derivative of the second function, which is cosine of bx plus c, plus the second function, since we have already found its derivative, so this time we are going to simply multiply it to the derivative of the first function, which is e raised to the power of ax. Now that is going to give us e raised to the power of ax. Now we have cosine of bx plus c. So if we imagine that bx plus c is x, then the derivative of the cosine function should give us negative sine bx plus c. But since it's not actually x, so we need to multiply it to the derivative of the imagined value, which is bx plus c, plus cosine of bx plus c multiplied to, so we have derivative of the exponential function, but here instead of x we have ax. So we're going to imagine that a times x, simply x, then that should give us e raised to the power of ax. But since it's not, so we multiply it to the derivative of the imagined value, which is ax. So this is the chain rule. So this finally gives us e, so we have negative e raised to the power of ax multiplied to sine bx plus c. The derivative of bx plus c is simply going to be equals to b plus cosine of bx plus c multiplied to e raised to the power of ax times the derivative of ax is going to be a. So a being a constant, we can pull it up to the derivative, and derivative of x is simply going to be equals to 1. Now we're going to take e raised to the power of ax as the common term. So we write the positive term first, which is the second term. So we have a times cosine of bx plus c. Then we subtract the first term, which is b times the sine of bx plus c. So this is going to be the derivative of our given function with respect to x. So let's move on to the next question. So here we have the given function. So we need to find the derivative of this particular function with respect to x. So let us try to find it out by using the quotient rule. So we have e raised to the power of x minus e raised to the power of negative x whole squared in the denominator. Then we begin with the function in the denominator and write it in the numerator. So this is the function in the denominator. So this will be multiplied to the derivative of the function in the numerator, which is e raised to the power of x plus e raised to the power of negative x minus the function in the numerator, which will be multiplied to the derivative of the function in the denominator. So that gives us e raised to the power of x minus e raised to the power of negative x multiplied to we have e raised to the power of x minus e raised to the power of negative x whole squared in the denominator. Okay, now coming back to the numerator, so we find the derivative of the numerator. So we have derivative of the exponential function gives us the exponential function itself. Now we have to find out what is the derivative of e raised to the power of negative x. So what we're going to do here, we're going to imagine that negative x is x. So that should have given us e raised to the power of x. But since it is not, so we are going to we'll have to again differentiate negative x with respect to x. So differentiation of negative x is -1, so that gives us minus e raised to the power of negative x. So this is the derivative of e raised to the power of negative x. So let's write it down here. So we have e raised to the power of negative x minus e raised to the power of x plus e raised to the power of negative x multiplied to derivative of the exponential function is the function itself. Now we have minus of the derivative of the derivative of e raised to the power of negative x. So that is minus of minus e raised to the power of negative x. So we have e raised to the power of x minus e raised to the power of x. It's appearing twice, so we can write it as whole squared. Similarly, we have e raised to the power of x plus e raised to the power of negative x appearing twice, so this is whole squared. So that's because this negative and negative is getting multiplied to make it positive. Whole divided by e raised to the power of x minus e raised to the power of negative x whole squared. Now we're going to expand by applying the identity a minus b whole squared, which is simply e raised to the power of x whole squared plus e raised to the power of negative x whole squared minus 2 times e raised to the power of x times e raised to the power of negative x minus e raised to the power x whole squared plus e raised to the power of negative x whole squared plus 2 times e raised to the power of x times e raised to the power of negative x whole divided by e raised to the power of x minus e raised to the power of negative x whole squared. So we have e raised to the power of twice x plus e raised to the power of negative 2x minus 2 times e raised to the power of x minus e raised to the power of 2x minus e raised to the power of negative 2x plus, so this becomes negative 2 times e raised to the power of x minus x whole divided by e raised to the power of x minus e raised to the power of negative x whole squared. So we cancel out all the terms, that gets cancelled out. That leaves us with negative 2 times e raised to the power of 0 minus 2 times e raised to the power of 0 divided by e raised to the power of x minus e raised to the power of negative x whole squared. So that gives us negative 4 divided by e raised to the power of x minus e raised to the power of negative x whole squared. So this is the derivative of our function this is the given function. So when we find its derivative with respect to x. So let's move on to the next question. So we have to determine the derivative of the logarithmic function given by log of a plus b sine x divided by a minus b sine x. Now if we treat, or if we assume that a plus b sine x over a minus b sine x is x, then we have the derivative of the logarithmic function will give us 1 over a plus b sine x divided by a minus b sine x. Now since this is what we imagined, that's equivalent to x, so that means we need to multiply the entire value to the derivative of this imagined value, which is a plus b sine x divided by a minus b sine x. So this should give us a minus b sine x divided by a plus b sine x. Now this will be multiplied to the derivative, so we'll determine the derivative by using the quotient law, the quotient rule. So we have a minus b sine x whole squared, and in the numerator we have a minus b sine x multiplied to the derivative of the numerator, which is a plus b sine x. That will be minus a plus b sine x, that should be multiplied to the derivative of a minus b sine x. So we can cancel out one a minus b sine x from the numerator and the denominator. So we have a minus b sine x multiplied to derivative of a being a constant with respect to x will be 0 plus b times derivative of the sine function is cosine of x minus a plus b sine x multiplied to derivative of a with respect to x is 0 minus of b times derivative of sine x is the cosine function divided by, we have a plus b sine x multiplied to a minus b sine x. So that gives us so we can take, if we multiply this negative with the negative b, so this will become positive. That's been done so that we can take b cosine of x as the common term in the numerator. That leaves us with a minus b sine x plus a plus b sine x. Now that the term in the new denominator is having the form a plus b times a minus b, which is a squared minus b squared. So b sine x and negative b sine x in the numerator cancels out. So that gives us 2a b cosine of x whole divided by a squared minus b squared sine squared x. So this is the derivative of our function with respect to x. So this is the given function. So let's write it down here. So this particular value of this function is 2ab cosine of x divided by a squared minus b squared sine squared x. Let's move on to the next question. See, here we have to obtain the derivative of the given function with respect to x. So let us begin by assuming that the argument of the logarithmic function, we just imagine it to be equals to x. So that means we only have to find the derivative of log of x. So that should give us 1 over x, which is the derivative of the logarithmic function. So x here is tangent of pi over 4 plus x over 2. But since it is not, so we're going to multiply it to the derivative of the imagined value, the imagined x, which was actually 10 pi by 4 plus x over 2. So this is known as the chain rule. So we have 1 over tangent of pi over 4 plus x over 2 multiplied to derivative of the tangent of, now this time we are going to imagine that pi over 4 plus x over 2 is x. Then the derivative of the tangent function should give us secant squared pi over 4 plus x over 2. Now since it is not actually x, so we again need to multiply it to the derivative of pi over 4 plus x over 2. So now we are going to rearrange the values. So we have 1 over tangent of pi over 4 plus x over 2. So secant squared can be written as 1 over cosine squared pi over 4 plus x over 2 times derivative of pi over 4 is 0 and derivative of x over 2 is going to be equals to half. So this gives us 1 over 2 times, so we have tangent, so tangent can be written as the ratio of sine pi over 4 plus x over 2 divided by cosine of pi over 4 plus x over 2. So this will be multiplied to cosine squared pi over 4 plus x over 2, and we have already taken care of the half, so we can cancel out one cosine from both the numerator and the denominator. So that leaves us with 1 over 2 times sine pi over 4 plus x over 2 multiplied to cosine of pi over 4 plus x over 2. Now we know that 2 times sine theta times cosine of theta is simply equals to sine 2 theta. So we will apply this particular formula here. So that is going to give us 1 over sine 2 times pi over 4 plus x over 2. Now when we multiply the 2 to the argument of the sine function, so that gives us sine of pi over 2 plus x. Now we know that sine 90 plus theta, so we know that sine pi over 2 plus theta is simply equals to cosine theta. So that gives us 1 over cosine of x, and the reciprocal of the cosine function is secant of x. So that means the derivative of this particular function is simply equals to secant of x. So here we have to determine the derivative of the given function. So let's do it step by step. So we can rewrite the given function as log of sine x squared over 3 minus 1 whole raised to the power half. So we converted the square root to the exponent of 1 over 2. So this has been done so that we can treat the entire logarithmic function as x, and this becomes, if we consider it to be equals to x, then this becomes equivalent to the derivative of x raised to the power of half. So we can apply the power rule. So that gives us half of log of sine x squared over 3 minus 1 whole raised to the power half minus 1 multiplied to the derivative of the assumed value, which is log of sine x squared over 3 minus 1. So we have 1 over 2 multiplied to log of sine x squared over 3 minus 1 whole raised to the power half minus 1 is negative half multiplied to the derivative of the log function. So if we treat the argument of the logarithmic function as x, so that gives us 1 over sine x squared over 3 minus 1. Now we need to multiply it to the derivative of sine x squared over 3 minus 1. So that's what we are doing with the chain rule. So we have 1 over 2 times, so bringing the negative half to the denominator. So we have sine x squared over 3 minus 1 whole raised to the power of positive half, multiplied to 1 over sine x squared over 3 minus 1 multiplied to the derivative of the sine function is cosine of x squared over 3 minus 1, which will be multiplied to the derivative of x squared over 3 minus 1. So we have 1 over 2 times the square root of log of sine x squared over 3 minus 1 times, so we have cosine over sine, so that will be cot x squared over 3 minus 1 multiplied to derivative of, let's write it down, we have 1/3 of the derivative of x squared minus the derivative of 1. So finally we get cot x squared over 3 minus 1 divided by 2 times the square root of log of sine x squared over 3 minus 1, and we have the derivative of x squared, which is twice x, so that gives us 2x over 3 minus 0, so we drop the negative 0. So this is the final derivative of the given function. So here we can cancel out the 2 from both the numerator and the denominator. So we finally have x times cot of x squared over 3 minus 1 divided by 3 times the square root of log of sine x squared over 3 minus 1. So this is the final derivative. Let's move on to the next question. So here we need to find the derivative of the logarithmic function. So here we're going to assume that the argument of the log is x, so that should give us 1 over x plus square root of a squared plus x squared. So that will be multiplied to the derivative of x plus square root of a squared plus x squared. So we have derivative of the first term, which is x, plus derivative of the second term, which is a squared plus x squared raised to the power of half, which gives us derivative of x, which is 1, plus here we can assume that a squared plus x squared is equivalent to x, so that means we can apply the power rule. So we have half multiplied to a squared plus x squared raised to the power of half minus 1 multiplied to the derivative of a squared plus x squared, and that is going to give us 1 over x plus square root of a squared plus x squared. So we have 1 plus 1 over 2 times a squared plus x squared raised to the power of half times, so we have derivative of a squared, so that will be 0, plus derivative of x squared, that will be 2x. So we can get rid of the 0 here, so we are left with 2x, so the 2 in the numerator and the denominator cancels out, so that leaves us with 1 over x plus square root of a squared plus x squared multiplied to 1 plus x over square root of a squared plus x squared. Now we combine the two terms within the parentheses, so that is going to give us 1 over x plus square root of a squared plus x squared multiplied to, so the common denominator will be square root of a squared plus x squared. So we have square root of a squared plus x squared plus x. So we have a common numerator and a denominator, so that cancels out, leaving us with 1 over square root of a squared plus x squared. So this is going to be the derivative of our given function with respect to x. Let's move on to the next question. So here we need to obtain the derivative of the given logarithmic function. So before finding the logarithm, so what we're going to do is we're going to rewrite the function such that we have, so what we're going to do here is we're going to remove the square root here and rewrite it as the exponent half. So this has been done because we know the property of log, which says that log of a raised to the power of b is simply b log of a. So that gives us 1 over 2 times log of 1 plus sine of x divided by 1 minus sine of x. Now we can apply the other property that log of a over b is simply equals to log of a minus log of b. So we have half times log of 1 plus sine x minus the half will also multiplied, so we have minus half times log of 1 minus sine x. Now we're going to find out the derivative, so we apply the derivative, so that gives us half times the derivative with respect to x of log of 1 plus sine x minus half times the derivative of log of 1 minus sine x. So let's rewrite it. So this is the derivative of log of square root of 1 plus sine x over 1 minus sine x. So this gives us, so we have half times derivative of the logarithmic function is simply 1 over 1 plus sine x. So this will be multiplied to the derivative of 1 plus sine x minus half times derivative of the logarithmic function is 1 over 1 minus sine x multiplied to the derivative of 1 minus sine x. So we have 1 over 2 times 1 plus sine x multiplied to derivative of 1 is 0 and derivative of the sine function is cos, so let's write it down as 0 plus cosine of x minus half multiplied to 1 minus sine of x multiplied to the derivative of 1, which is 0, minus derivative of the sine function will be negative cosine of x. So that gives us cosine of x over 2 multiplied to 1 plus sine x. So we have negative 1 multiplied to negative cosine of x. So that will become positive cosine of x whole divided by 2 times 1 minus sine x. So let's combine the two terms. So we have 2 times 1 plus sine x multiplied to 1 minus sine x. So cos of x will be multiplied to 1 minus sine x plus cosine of x multiplied to 1 plus sine x. So we have in the numerator cosine of x minus cosine of x times sine of x plus cosine of x plus cosine of x times sine of x whole divided by 2 times, so we have 1 squared minus sine squared x. So here we have applied the identity that a plus b times a minus b equals a squared minus b squared. In the numerator, negative cosine of x times sine of x cancels out, positive cosine of x times sine of x, leaving us with 2 times cosine of x in the numerator, whole divided by 2 times. So we have 1 minus sine squared x. So 1 minus sine squared x is actually cosine squared x. That comes from the fact that cosine squared x plus sine squared x is equals to 1. So we can get rid of 2 from both the numerator and the denominator, and 1 cosine x from the numerator and the denominator. So that leaves us with 1 over cosine of x, and the reciprocal of the cosine function is secant of x. So this is the derivative. So you can say that the derivative of this particular function is simply equals to secant of x.